Hello guys and welcome to another stream. Let me just set everything up here because I think we still need the chat on the screen just so you guys don't think I'm talking to myself. Everything up here because I think, and hopefully the actual volume of the music compared to my voice is okay, and I can probably just test that by turning off the music for a bit and listening to myself. We still need the chat to my voice is okay, and I can probably just test that by turning off the music for a bit and listening to myself. Yeah, I mean, it's still a little bit loud, so I'm gonna turn down the desktop audio a little bit. And yeah, we should be good now. And now let's get that chat up. Okay, good. Can you guys see the comments? I'm hoping you can. Okay, so this. Okay, we're good to go. Just so I can do a test, let's put a little hello there. Yep, and it seems to be kind of working fine. Except I closed it. No problem, no problem. We can go back and put it back up again. No problem. Tell you what, setting up the stream is always the hardest part of the stream. Gotta say. Something always doesn't work, so. Yeah, now we're fine. Now we are fine, and the kind of blending of the screen here, you can't really see it very well unless it's, I guess, against a dark background, but yeah, we'll have to do this, unfortunately. And we're also missing the Spotify link, aren't we? Let me resolve that by simply deleting it and creating a new one. Display capture, window capture should be. Okay. Good. So we should have that back up again here. I'll put it at the very top. And yeah, let's start coding. Let's start coding. I'm gonna just load up the. Good. Yeah, I don't think there's anyone watching now, but this is where we start anyway, just so I can document myself coding. So the other day we actually stopped where I managed to get all the URLs being crawled, like recursively, and then I said that in the upcoming days I'll probably be making this this crawler a little bit more like efficient by using maybe different threads or a thread pool to actually run multiple requests. And today I'll actually try and do that. But before that, I actually want to kind of refactor some of the code. I want to just go over this and just make sure that we can refactor some of it, because some of it does look quite ugly at the moment. And on top of that, we can actually create a library that will just do the crawling itself. So my idea is to have a library where you give the link and then the type of data that you want, and then it would return you or save all that data to a directory, as well as the links that I found. So that is the plan for today. Just work towards that goal. Okay. So yeah, let's start. Yeah. So the first thing I kind of noticed as soon as I opened the code today is that we can probably sort of like refactor some of this out in the get URL function. And this function is what's kind of turning relative URLs into absolute URLs, I guess, or full-on URLs in my code. And because obviously some of the links actually come in this format here, as you can see, if you scrape google.com, you're going to get an href with the value / services. So we have to turn that into an actual link that we can then passed to our crawler, right? And this is what's doing that conversion for us. So given the root URL and then the path, it returns us a result, okay? And then this is kind of what it looked like before. It doesn't necessarily look good, the function itself. I particularly don't like it when we're using a lot of match clauses in Rust. I think it doesn't quite look very readable. So I'm wondering if I can turn this sort of operation into a more sort of rustic syntax, I guess. Good luck with your channel. Oh, hi AJ. Thank you for watching, and yeah, thank you for the wishes, man, and good luck on for you as well, whatever you're doing, whether you're studying or looking for a job. I wish you good luck. So yeah, thanks for tuning in. So yeah, let's actually try and turn this into a little bit more friendly. So what we're doing here is like we're asking Rust to parse the URL or the path here, and this function may or may not return a valid URL object. If it's a valid URL object, it means that the URL is actually a whole sort of domain, kind of like this one here. So https google.com is a valid URL. However, if it tries to parse something like /services, it will return me an error, right? So this is kind of what this is doing. It's actually just doing a switch here on the result of this, and if it's an okay result, that means we have a full-on URL, or if not, we simply return the joined result from root URL and the path. So it's going to try and join these two results to make it a full URL. Now this is okay, it does compile, but it'd be nicer if we can do it in a more of Rust way, I guess, using maps and functional I guess functional syntax. I'm talking too much and not drinking enough water, so it would be nice if I can sort of use the question operator in Rust to basically just either return the valid okay result of parse or throw an error. However, parse returns a Rust error, not an anyhow error, which is what I'm kind of using up here, right? So I don't know how to sort of convert from Rust results to anyhow results. So let's have a look at that. So Rust converting result to anyhow result. And as you can see, I've searched for this quite a lot before, and this seems to be a common sort of issue in my code. This is just because I use the anyhow result, I guess. Yeah, so I've actually seen this article before. It explains why you should use anyhow, and then it talks about sort of like using I guess the question operator with the standard results, and then how it doesn't really cascade up, but anyhow cascades a little bit better, so you can kind of convert errors into different errors a little bit easier, I guess. But now, does this have any code for converting between the others? There you go. What does this do? Ah, yeah, okay turns into an optional, which is, I guess, good, right? Yeah, I guess we can lose the error information. So we can do okay or, and then we can also do, yeah, I mean we can just get rid of the whole thing here, and then kind of just turn this into a one operation thing. Except I'm doing two conversions here, so is that really pretty good. I'm not entirely sure. Let's see what else this is going to do. There's nothing regarding converting Rust results to anyhow results, and that's kind of annoying. Let's see, Rust map result, so anyhow result. Maybe I'll just do something very lazy here. Oh. In fact, what we want to actually do is join here. I just want to see the type, so I'm just going to do a test here. This returns me an error. What if I did this now? Ah, great. Now I can do it. There you go. This is a little bit better. So we fail. Ooh, what did we do here? Ah, yeah, we don't need that actually. That's it. So yeah, I mean, I don't like this kind of okay there, just to turn the standard result into an option, just so I can turn it into a Rust error later on. But we'll leave it here for now. I think it's a little bit more readable than what we had before. Yeah. So I'm fine with that. We don't need bail anymore. And yeah, I mean, let's look into how we're actually saving the URLs before, because I think we had an issue, didn't we? I think that in the main code, I was using a queue to sort of like store all the URLs that we can essentially visit, and then a set to store the already visited URLs and the ones that we have kind of already checked out, right? But there was something that I think someone called Antonio, actually Antonio is the person that seems to join the stream quite a lot, suggested, which is to check the result type, right? So the result type for the response, which means if it's not a 200, we kind of ignore, and we also give it a very short sort of like timeout, so we don't hang our API. So let's see how we can do that. So request get is the function we're using, right? For a single request, you can use get. It doesn't really take any kind of timeout or anything like that, I guess. So we probably want to actually use the client itself. Wishing to only make a few HTTP requests, blocking API may be more convenient. No, we want this one.
I think there's an app called Excalibur or something, right? Yeah, there you go. I just want to sort of like quickly sort of put down the idea that I have in my mind of how this should work, right? So ideally, how do we do here? There you go. And also, can I change this so it's a little bit canvas background? There is no dark mode, I guess. Oh, there is. There you go. Do we have grids in here as well? I saw someone using this at work the other day and I found it quite interesting. Reset the canvas, confirm. Yeah. Grid support. Okay, so now apparently they validate it. Command Control Plus. Okay, does it work? No, it doesn't work out. I'm just trying to put the grid. But anyway, we can do it without a grid. So say we kind of had like thread pools in here. Can I duplicate this? Control D, okay. And then this was, yeah, oh. I just want to select it. There you go. And bear in mind, because I'll show you what I mean in a second. So this is like a thread pool, just waiting for URLs to pop off the queue. And I kind of want to get Tokio to do this for me. But what I have is, I've done this wrong as well, because I should have kind of just, does it not work like that? I should have just done the first, this obvious thing first, which is doing one of them. Okay. Oh, where's text? I guess T. Okay, where's T? And this is my request worker or something, right? And what this essentially is doing is like just a, I guess a get request or something like that. So get request on URL. Or whatever, right? This just says what it's kind of doing. Wait, this is inside the thing? That's interesting. There you go, this is what I wanted to do. Just have something separate. Can I make it bold? Is that a thing? It is not a thing, but that's fine. Yeah, so the idea here that I've got in my mind is to have sort of like multiple of these. Say we've got like just 4 for now. That's absolutely fine. Hello. I don't know how to pronounce the name, dude, so I guess you're... That's a Russian name, right? So it's a little bit difficult for me to read. But welcome to the stream.
I wish I spoke Russian. Unfortunately, I only speak Portuguese and English. So this is the idea. Ukraine. Oh, welcome to the stream, dude. How's it going? I actually work with some people from Ukraine. Two very nice guys. Whereabouts in Ukraine are you from? I'm just drawing out the what I'm trying to code, just so I don't know if it makes it easier for me to actually think about it or not, but this is what we're going to try and get out of the stream. Right, so the idea is to have this kind of behavior here. So like we've got the URL queue, right, which is a queue of URLs to kind of to crawl, and then out of this sort of like, I guess each one would have a connection really to this, and then you can see the idea. So each kind of like thread would be able to pop from the URL queue. So we may have something like google.com, facebook.com, twitter.com, and each worker is going to crawl exactly one URL. So it's going to request the HTML from that page, and then it's going to see if it finds any assets that we want to kind of save. And then each one of these will eventually, let me just change the color of this one so it makes it a little bit easier. So each one of these threads will then be able to add these sort of URLs that I found, or these assets that we want to keep, into my URL database. It's not necessarily a database yet, it's just somewhere that I'm storing the URLs. Okay, but this is the main logic for this. Very simple. There's no architecture in this at all. It's just a very simple kind of have a thread pool, do some work, and then store the results somewhere else. This is kind of what we're doing here with the code. Now, what I need to do is, like, currently all the crawling is done in one main loop, right? So I've got this crawler loop that's actually popping a URL from the queue, and then adding all the links that it finds from that URL back onto the queue. And then just, repeating that until we have already visited the number of links that we want, right? But I'm going to change it slightly. So maybe we have this in an actual library somewhere where we have some sort of like crawl function that will take in a URL and then return the number of links that you requested. But that library is actually going to have some thread pools in there, right? So yeah, let's look at how to actually do this kind of stuff with Tokio, because I have no idea. Tokio thread pool or something, right? I mean, we can definitely take a look at this, but I think the very first thing to do would to actually encapsulate all of this crawling into a function, right? So in other words, instead of having the main logic here on my main, I have another function, maybe an async function called crawl or something, right? I already have crawl URL. Let's just call this one crawl, and then we change the name slightly. So this will take the URL to crawl. And kind of return me a result. I don't know which type, just a result for now. Either fail or success, right? And then in here I can put this main loop. Alright, I can put the main loop in there. So we should call crawl here at some point. Yeah, we probably also want a reference to the queue. So instead of the URL, so we want the link queue, right? Now, can this be a vec deck here? It could, but it has to be thread safe, and I don't think vec deck by itself is thread safe, and Rust is probably going to complain about that, right? It's going to complain about the fact that I'm trying to access the same link queue in multiple threads when I do spawn them. So ideally we would have some sort of type that is thread safe for this queue, and I think arc is one of those. ARC in Rust. So it's just a reference counted atomic operator, basically. So it provides shared ownership of value t allocated in the heap. Invoking clone on arc produces a new arc instance which points to the same allocation on the heap as the source arc, while increasing the reference count. When the last arc pointer given allocation is destroyed. Does this have a lock in it? That's my question. Shared references in Rust disallow mutation by default, and arc is no exception. You cannot generally obtain a mutable reference to something inside an arc. If you need a mutate through an arc, use mutex or read-write lock, or one of the atomic types. Mutate through an arc. Okay, so we need to use arc with read-write lock, right? So this is basically what we're gonna do. So we're probably gonna have a struct here called the crawler state or something. We put all the state trackers in here, I guess. But this is just a link queue, I guess. That's what we're gonna have. And that itself is gonna be a read-write lock of a vec deck of a string, right? That's basically it. Now we need to import read-write lock. There is a Tokio one as well as. Let's use the Tokio one. I assume they do the same thing. I don't know, but yeah. And we can do something like use. Is it use to do a type def in Rust? Can't remember now. I think it is, right? This is where I wish I had some Rust people here. Yeah. I'm not sure if there's anyone watching, but if you're watching this and you know Rust and you want to correct me on anything, feel free to do so. Rust type defs. Yeah, just type, I guess. Cool. Okay, good. So now we can do this. The interesting thing is that we can actually put something like, you know, the max links, something like that in here. This can be a U32 for now. We don't care about that. And then the already visited URLs too, right? That's what we need. So already visited. This has to be a read-write lock of a, again, I think it was a hash map, right? That we had a hash set of strings. So this is gonna What's not? Oh yeah, string. This is going to keep the links to visit. Already visited is going to keep the links we've already visited, and so on and so forth. And then the max links is just the number of I guess links that we want to crawl up until. Right. So yeah. Let's try this. So instead of this, we have this is what's interesting. Because we're going to have to do several locks here. So we want to firstly lock the queue here, right? Because we want to check if it's empty or not. And we also want to check already visited. So I guess what we can do is we can let the state. This is a pattern I see a lot of work in other programs online. This arc and read write lock thing. So crawler state dot read, right? We just want to read in here. Actually, want to do a link queue there. Is read a thing? Oh no, this will be link queue dot read. And I've got a message. Just give me a second. Yep, cool about that. We have read here, but this is async. Yeah, this is async, so we have to await. I'm fine with that. And then we also want to basically do the same, but for the already visited. And then it's kind of the same, right? So we just do this crawler state dot max links. That's fine. Already visited, it should be. And this is still not expected use size, found 42. What was max state? Max links there. It's use size. Okay, yeah, we can do that. We can just change this to use size, whatever that is. What it actually is this type? Because I have no idea. It's like a 32-bit integer, or is it a 64-bit integer on my machine? I have no idea. Break crawler. Mismatch types. Expected results found enum. Alright. So I guess what we need to do here is either return an OK. There. And then we just slowly kind of refactor this a little bit. See, so I kind of need to pop something from the link deck, from the link queue here. So instead of a read, I need a write in this case. And I also need this to be a mute, I believe. And then once I have the URL that I've sort of like cloned out, I can simply just drop that link queue because I don't need it anymore. And this kind of allows other threads to work with that queue now as well, right? So I just kind of popped it to do the checks. And yeah, that was it. And already visited, you know, after this as well, I can drop it, I guess. Because then the lock is released in this case, right? Okay, cool. Now this stays the same. We still have that URL to crawl. And here for each link in links, which ones are the links? Yeah, I mean, this is important here because now what we need to do is we need to add it to the already visited, I guess, or the queue. So basically I'm gonna have the same code twice here. So except this is also a reader now. Write, sorry. And this is also a mutable right here. Okay, so this should be, I mean, very quick and dirty, but you know, is the equivalent of the multi-threaded version of my crawler loop. This has not been used anywhere. Yeah. Instead of crawl URL, I could just call this find links, I guess, because that's what this function does. It doesn't really crawl it, it just finds the links, right? So again here, find links. A little bit better. And then here we can just simply call that function, right? So we have crawl, and we have our state, right? So we need the state. And we can just do that. We can let mute crawler state, or let crawler state, I guess. Oh. And what do we need here? Field struct fields. Yeah, I love that. So link queue. What should it be? Read write lock of that. How do I initialize a read write lock? I didn't actually check this online. Read write lock of new. Okay, cool. So let's try that. And this, the link queue should be a vecdeck, right? Vecdeck, or just a default. Default. Rust knows here, right? Yeah. Same for this one. Read write. Let me actually check the. Hello, Wolfox. How's it going? Thank you for watching, man. Sorry, I only saw the comment just now. I had everything down. We're basically www. You don't have to spam it that much, dude. I don't want to have to block your account. But welcome to the stream. We're just doing some Rust code to sort of like turn this web crawler into sort of like a multi-threaded thing. Okay. Now let's say the max links is 1,000 in this case. So are you a programmer? What do you usually program in, dude? Do you do Rust? Do you do C++? How have you found the channel before? Are you still using Virtual Studio Code? I'm using Visual Studio Code, yeah. So Visual Studio Code is actually quite good. I'm doing Rust right now. This is a Rust project. And the tools that we have in here for sort of like code completion and whatnot are really, really good. So I'm seeing no reason to use anything else at the moment. So yeah. What about you? What do you use, man? Do you use Visual Studio Code as well? Do you use Vim or something more advanced like Visual Studio itself, or I don't know, C-Lion or something? I don't even know what you're programming. You haven't really said yet. So it's hard for me to guess. Crawler state. Already visited. No, read, right? Yeah. I also use Virtual Studio Code. Yeah, I mean, I use Visual Studio Code. I think Virtual Studio Code is probably something different, right? It's a little joke. I know what you mean though. So why is this not working? And also, do you know HTML? Yeah, I've done a lot of HTML in my time. I don't know the new stuff. There's HTML5 now, and you know, it's very, very advanced compared to what I used to do when I was like very young, but I do know it. Unused result. What about you? Are you doing HTML now? Is that what you're kind of doing currently? Are you learning HTML? I don't know much HTML. Yeah, I mean, it's a very basic kind of syntax, isn't it? It's not even a language, but it's not hard to learn, dude. This requires very little HTML. But yeah, let's have a look at whether or not this compiles. This is a web crawler, so it goes through pages and then finds links at the moment. That's all it does. It seems hard. No, dude, I think HTML is definitely easier than an actual programming language, because you don't really have any logic. It's just basically copying and pasting things online when you want to do something, right? So let's see if my thing still debugs. Rusty finished. Ooh. That doesn't look right, does it? So my program ran instantly, which is not really right. So there's definitely something wrong in here. Definitely something wrong in here. Oh, yeah, that's why. It's because I don't really have anything here. In my link queue to start with. That's it. So it doesn't really do any crawling at all. Backtack from. Okay, that kind of works. So and I can do something like args.starting URL, right? Is this some extension showing all the type hints? No, this for Rust. So for Rust, I don't really have many extensions. It's just I think Rust Analyzer and code LLDB for debugging. But yeah, it does a good job in showing the type extensions and whatnot. I think if you mean this is from Rust extensions, so it's quite helpful actually. So yeah, I'm trying to see if this still works, if this crawler still works. So we've got the arg.starting URL here. Yeah, this should compile now and actually do something, I guess. I'm going to turn this into a multi-threaded application by basically, I just put all the crawler logic in here, so I can call this async function over and over again with Tokio. Hopefully this is going to be running on multiple threads or something, I don't know. What's the difference between a web crawler and a web scraper? Dude, I don't really know, to be honest. I think web scraper is mainly programs that kind of like crawl the web. Obviously it finds links and whatnot, but also look for data. So like if you're looking at an image scraper, it will crawl the web, it will find all the links, but it will also like save all the images somewhere, right? So that's what a scraper does. It just scrapes data. I think that's the main difference really, but you know, don't quote me on that. Do your own research. Just type in on Google, and then you might find the information you're looking for. I gotta go, bro. Bye. Thank you, Wolfox. Thank you for joining the stream. And yeah, I'll see you later, bro. Good luck. Now let's see if this still compiles. There you go. So it is finding links on my website, still as expected. I'm not gonna let it run because it's gonna run until it finds 1,000 links. And as you can see very quickly, this is too slow because I've only got one agent doing all the GET requests in one thread. And some of them take forever to return. So And crucially, I only add the links to my sort of list of already visited or my database if it already visits that page and finds all the links in there. So this is, finding 1,000 links is going to take a while. So I'm going to not run this for now. It kind of works very slowly, but we still have a lot to improve. First of all, I'm going to put this function to run a few times. So like in a thread pool almost, but with Tokio. So let's see how we do that with Tokio, because essentially this is just an async function, right? So it should be ready to be, to run in a different thread with Tokio. And Tokio, if you don't know, is the sort of like async backend here in Rust. So it's a very popular library that allows you to write async code very, very easily. Much easier than, in my opinion, the new C++ stuff. So that's what I'm using here, right? So I'm gonna do some Googling very quickly. Hope you guys don't get too bored. Tokio thread pool. CPU intensive work in Tokio. I don't really have that CPU intensive work. It's more like a network thing. But yeah, I hate that you have to install an entire library just to get an async runtime. Yeah, Rust is unfortunately good in some aspects, and the async runtime it doesn't come with an async runtime, does it? I don't think it does, but yeah, that's not ideal. But still, I mean, it's not a bad language. I feel like I write less bugs in Rust than I do in C++, for sure, because of the helpful compiler messages. But yeah, Tokio has a thread pool. If your code is CPU bound and you wish to limit the number of threads used to run in, okay. My code is not CPU bound. Async moved away. Oh, what is that? I saw it the other day. I think it was at work actually. It was futures, block on or something. No futures. List, unordered list or something. Future trades away. It's pretty much messed up in Rust. You think so? Yeah. I find it, when I started it, I found it very difficult to kind of wrap my head around it, because I've always just used kind of like just threads in C++ really. I never really got to use the async stuff in the modern C++, just at work at least, but I've used it for personal projects now. So it was pretty much like a new concept, but it's just essentially a glorified thread pool, isn't it? That's basically what Rust or what Tokio is. So once you understand that, you kind of understand how things work. Can be filled with collecting iterator, features in order. All right, how do I use this? So my idea is to basically spawn 4 of these crawl functions in a sort of like a pool, and asynchronously run all of them. That's what I want to do. I still don't know how to do that after Googling, but I'm pretty sure that this helps us. Futures unordered in futures unordered example. Let's quickly read this. I'm going to turn it up here so you guys can read it with me if you want. An efficient way to manage multiple futures in Rust. In this post, we're going to explore futures stream, futures unordered, a mighty and efficient tool for juggling multiple asynchronous tasks concurrently. This is what I want. Yes, this utility allows us to poll multiple features in a non-blocking manner, automatically handling the completion of individual tasks and yielding their results as they become available. See, I wish some of my my blog posts were sort of as clear as this here. I write blogs as well, but some people are just better at writing blog posts than others, I guess. Yeah, so I need futures, definitely. And my Tokio, my cargo tunnel. And where does that go? Right here. and let's create the asynchronous functions. Yeah, this is pretty much what I have with my crawl function. We define 3 asynchronous functions, task 1, task 2, and task 3. Cool. And then they have Tokio sleeps in them. I don't really have that. Okay, so this is what I wanted. Cool. This is exactly what I wanted. So this is like a pool managing the asynchronous threads, right? So in theory, if I do something like this, ooh, right, what the hell is this? Pinbox, future output. First of all, let me just import this. So it's creating a worker thread. Yeah, basically, it's creating like a few worker threads, and then this is the pool that manages the threads. That's what I'm trying to do. Dana J. I'm hoping I'm spelling your name right. Let me know if I'm not. Sorry, pronouncing. Now, where does this come from? Pin, okay. Okay, as well. I don't like this declaration. I feel like Rust should be able to just deduce the parameters here, right? No? Type inside the sync must be known in its context. It cannot. Okay, yeah, fair enough. And then the output equals string. The output is equals result in my case. I'll tell you what, that's a chunky thing, right? So tasks, no. What is it? Push and box pin. Okay. Yeah, this is what I do now. So crawl. I want to put this inside my worker thread here, as you can see. So crawl, crawler state dot. Oh, what is Rust doing? So crawl and crawler state dot clone. Now this doesn't have an await in it, so it kind of just does, I guess, box pin. I don't know what this does, if I'm honest with you. I'm gonna have to search for it. But yeah. Now let's say I just spawn 4 of them. So this is essentially 4 worker threads running the same function, right? Variable does not need to be mutable. Oh, why not? Because I don't have that yet. What's this? No method next for features not ordered in the current scope. There is probably some sort of derive I've missed, right? Probably this one. Where's the features? Okay. Wait, what the hell? Features stream extension. Okay. Okay, I see 2 places where you have used drop and know that a function of drop is to manually free resources, but Rust does that for you while exiting the function. So that's the point here. I think it probably mean on this. Yeah, the reason here is that you see the drop in this case releases the lock. These types are actually, if you look at crawler state, which is crawler state ref, it's like an arc, which is like I guess a reference to this crawler state, but some of these types are read-write locks here, just because I'm using them in different threads. I should probably turn this into an atomic type as well. I don't know if it works like that. But the point is, like, I want to read some of these values at the start of the function. So I want to definitely be able to access the URL queue here, just to check if it's empty or not. And also the already visited links, because I want to check if the length isn't more than the maximum allowed number of links that I have. But then once that's done, I just want to basically release it for the next worker thread to be able to check these values as well, right? In fact, I only drop the link queue here after I pop something from the queue, right? So at this point, I've got the next URL here on this scope, and this is what owns that URL. I can drop that link queue because the next thread can go and kind of do the same, right? I can pick up the next link in the queue. Because if I just keep the lock, then that means I have to wait for the lock until the URL request or the get request here finishes, which, as you probably know, is a long time, right? I want to just free up all the threads to kind of be able to look at, you know, the queue here as well. I mean, if that's what you're asking about, this is, you know, this is the reasoning about it. So this is why I have to drop them for that lock to be released before the end of the function. That's all, or before the end of this iteration here, because it's a loop, right? But yeah, otherwise there's not much point in turning this into a multiple threads because it's not really gonna run in parallel, if it makes sense. And it's kind of the same logic when adding links that we found back to the queue and back to the already visited list as well. I have to acquire them again after as a write one instead, a write reference instead of a read. But yeah, that's it, dude. I hope that made sense. If it doesn't, let me know. But this is the bread and butter of the program, basically. Yeah, thanks God. It doesn't arc automatically take care of referencing counting. It does do reference counting, but it's not like the data inside it isn't thread safe, as far as I know. And that's what I got from their documentation that I literally just read 30 minutes ago. I'm not sure if it's correct, but it says here, where is it? Shared references in Rust disallow mutation by default, so they don't let you mutate the types inside it from the looks of it, which is why you have to use read write lock as a combination of with the arc, if it makes sense. I'm not sure if this is what he meant, but you know, this is what I've got in the end. So yeah, maybe I can remove one of them. I don't know. You've got a point though. I'll have to do that experiment. But yeah, let's see what's going on here. What's result? Print. It's not implement. Let's just log the error, I guess. Well, let some task, which is a result. Oh, okay, cool. Now, what do I do with errors inside my program? Do I just want to print them off? I guess I can match the result, right? And if it's okay, something, we'll do something. And if it's not okay, if it's an error, we also do something, but I don't know what something is. I guess I can just log the error for now and not exit the program. Hello, Antonio. Hola, amigo. Bom te ver de novo. So Antonio's been watching our stream for the past few days. He's been helping out in the code as well. We've done quite a lot now, Antonio. We've turned this into multi-threading, hopefully. Multi-threaded application. So hopefully it finds the links a little bit quicker now. And we'll see. One positional argument in format of a string. Of course he has. There you go. That's better. Yeah, nice. Yeah, I'm using Tokio with a combination of futures, whatever this type is here. Futures and ordered. I'm not sure if you've seen it before in Rust, but it's like a pool manager, a thread pool manager kind of thing, and then you write the worker threads in here. But yeah. What I haven't figured yet is whether or not... I And instead of breaking out of the crawler, yeah, I mean, I have to change this logic slightly here because I don't want to break out of my crawler if the queue is empty, right? I just want to wait, I guess, until there is a link on the queue. So what I can do is I can do link queue is empty. If it's empty, then we do Tokio sleep, Tokio STD. Wait, what's actually the sleep one for Tokyo? Tokyo time sleep, okay. Of course. Tokyo duration. Is Tokyo duration a thing? So it just has to be STD duration, I guess. Let's sleep for like a half a millisecond or something. No, millis, please. There you go. There you go. And then in here I can kind of, yeah, I can't drop that, yeah. But then in here I can just say if I've reached the maximum number of links, then I break out of the loop, if it makes sense. Okay, so okay, a little bit better. Yeah, the reason why I did this is because these crawl things would like finish straight away. They would just exit. The only one that would succeed is the first one because it actually has one link in it. So like the first one would get that link out and then it would be empty for the next ones. So yeah, we don't really want that, do we? Right, let's see if we can actually build it. Cargo build. Yeah, we've got new dependencies here, so it might take a little bit longer than usual. I definitely didn't drink enough water today. Let's see it now. Queue is empty. Okay, queue is empty. Cool. Huh? Queue is empty. Are you enjoying Rust multithreading? Is it very different from C++ multithreading? Seam. Yes, man. It's definitely a lot easier than C++ multithreading, right? Because it has a lot of structs and types that already help you, I guess. I just want a better package manager like Cargo in the C++ environment. I can finally bit fairer to other languages. Yeah, dude. I agree with you, Dana J. I tend to use Conan. Conan is a very good package manager, but it's definitely more difficult than just adding your stuff to your cargo.toml. I'll tell you that. And we got to figure out here why we get those errors, because that means we return it straight away, right? Yeah. So how can this ever happen though? How is the queue empty here if we've already checked that it's not empty? Ah, okay, so if it's not empty. My bad. Error by my side. Same, I understand why it's like that, but Cargo is beautiful. Yeah, dude. Cargo is amazing when you compare to the alternative in C++. I mean, I only really ever used Conan and VC package, and they're both pretty difficult sometimes. Especially when you're dealing with cross-compilation. Conan tends to be the nicer one, but there's a lot of setting up to do, I used to work for a car manufacturer called the Jaguar Land Rover, if you guys know the cars. And sometimes they had to like get some of the very fucked up libraries like OpenSSL to compile for the car's board, which was like a Snapdragon at the time. And yeah, man, it was a pain, very painful. But yeah, let's see now. see, we're still getting that. We're still getting queues empty. Ish. Oh, wait. And continue. It's continue, I think. Yeah. Kind of forgot about that, actually. We don't want to continue into here. We want to go into the next loop. And potentially wait again. And now we shouldn't see that error. I'm hoping. And the threads shouldn't exit. Right. But yeah, this is something we shouldn't really be exiting here. Should not exit the queue, the worker here. Now, why is nothing happening though? Now I'm worried. Now I broke my program. Okay, let's add some logs to it, because I have absolutely no idea what's happening, so... Just for the sake of it, let's add a worker number in here. A worker n, which is 942 or something. CMake is way too time consuming. Your video helped me make CMake when I was stuck on debugging. Thank you for watching, dude. Thank you. Yeah, I mean, by now I got quite used to CMake. I kind of like it at the moment. I think it's very flexible, but yeah, I mean, it's, you know, you don't have to write any sort of similar thing in Rust at all. You know, it's all done for you by Cargo. So, but at least you learn some, you know, some useful stuff about build systems if you learn about CMake, which should definitely help you, I guess. So hopefully it's still useful. I just want to see what's going on. I'm actually, you know, quite surprised to see that some of the subscribers know Rust and enjoy Rust, because I thought everyone would kind of hate it. But yeah. So we're waiting for all the threads. Waiting. Which is a bit weird. 1, 2, 3, 1, 2, 3. I mean, this is... It seems like we're not running in parallel here. That's what it's, you know, it's kind of looking like to me, to be honest. They're actually running in order and not in parallel, which is worrying. They should be running in parallel. But okay. That was a slight mistake in my logic, but you know, this should be, you know, if it's empty, not if it's not empty. Okay, so the thread one has actually, you know, gone and done it, I guess. CMake is flexible, but it's not beginner friendly. No, not at all. Yeah, I do agree. Oh yeah, good. CMake documentation is well written. I disagree. I think CMake documentation is terrible, but sometimes it becomes overwhelmingly difficult to find exact stuff. Yeah, I mean, I find CMake documentation extremely difficult to understand, even from an experience point of view. Because like what I could do is I could, for example, look at, I don't know, one of the CMake MSVC flags, right? You know, it just says kind of like, you know, multi-threaded is equals to empty. statically linked runtime library. It doesn't really say like what this implies in the code and like how statically linking libraries means you don't have to install like a C++ runtime or you don't have to have that C++ or Visual C++ runtime installed if you're kind of giving out a library or something like that, compared to the dynamic one. So it's very difficult to find like very specific things, as you said, but yeah. And then you look at like find package documentation and dude, that's even worse. There was an error here. Error sending request for channel closed. Channel closed. Cool. I started C++ but ended up trying Rust too because of the cargo on the book being beginner friendly. Yeah, the Rust book is actually very good. You are right. It's very beginner friendly indeed. What I could do is I could also have some sort of like output thread here that would just output the current state of the program. So something like a sync function output status or something, right? And that returns me a result. What do I need? I need a state here. Again, let's just do a loop. So is this how I do a loop? Yeah, crawler. There you go. It's like a loop label. What do I want here? I want to let my queue, not even that, so just the already visited, be the crawler state in the already visited dot read racing. Sorry, dot await. What am I doing? And then on top of this, I just want to print out what's already in already visited. Yeah, very nicely. So I guess I can do for each link in already visited. Why is this not working? Okay, now it works. I want to just log info. We don't even need a label in this case. Just a while loop. This gonna work? Yep. I also like the functional stuff Rust has. I find it pretty. Yeah, me too. I like having to write something, you know, being able to write something like this. .int, .clone, whatever. No, but for real, yeah, there are times it makes things a lot easier. Like this code here was a lot different the other day, and then today I re-looked at it, and I was like, yeah, this can just be a, you know, a join, okay, or after, instead of like matching this and making sure it's an error, and having like nested ifs and and matches and stuff. Yeah, it's quite nice. I still, you know, I say that, but look at this code here. I definitely could do with some refactoring on this and just turn it into all functional. I do agree with that, Antonio. Right, so it's just one more thing. Let's just log in for the number of links we have. I love pattern matching, yeah. I love not using it though, and nesting it. I hate when it's nested. I like it when it's not nested, because it's easy to understand, but when you have pattern matching inside pattern matching and whatnot, it becomes a bit difficult for me to read, in my opinion. Yeah, okay. Cargo build. Okay, yeah, I mean, this is definitely, we don't want to do that all the time. Let me just put a Tokyo time sleep here, please. Duration from seconds. Let's say we print it every 3 seconds or something. That'd be enough. What the hell is duplex stream? And why is it there? Cool. Let's see now. Number of links visited is 1 here. It's still very slow. And I'm not sure if making this multi-threaded did help at all. Like, we've only visited 2 links so far. Yeah, this is very slow, guys. Very, very slow. How to make a web crawler faster in Rust. Is that even an article? Meaty, crusty, fast, scalable, and polite broad web crawler built with Rust. Interesting. It would be nice to see how these people do it though. Crusty, that's a good name as well. Oh, this guy's got a graph too. Look at him. What is this graph showing though? Let's take a look. Top 25 most linked domains. YouTube, Facebook, Twitter. Nice. What is this, like Grafana kind of dashboard? I think it is, yeah, it's Grafana. Nice. This is actually very fancy. I like it. I'm jealous of this guy's web crawler because mine only does. It's only visited 4 links so far. But what if I start with google.com though? Let's see how fast it does here. We shall surpass him, yeah. We shall do it. It's still very early stages. Like, obviously there's a bottleneck somewhere. I don't know where. But it's definitely not doing links as fast as it should do. Where's my terminal? There you go. Right, and now there's a deadlock somewhere. Amazingly. Even worse. Or are we just blocked by Google? Because I have no idea. Let's try again. Finds all those links. Okay, good. Found link. Cool. So you get stuck on this one. Or in fact, let's see what's actually going on if we put a log again just before we visit the link. Request. So if we do here log. Crawling or finding links inside. I still have to implement your suggestion, Antonio, which is just to look at links that return 200. So maybe we can do that now. Finding links inside this. And it'll be URL. URL.asString. Actually, in 2 we'll do, right? Nope. Cool. Yeah, let's look at this interesting thing here, because we can actually just what we want to do is make sure that we only consider pages returning 200, right? That's what we want to do. So we can do a let response be the request, yeah, and then we've got URL.clone. Does this take a URL? I guess so. And I wait till now, right? And we want to do that. We want to make sure that it has a response. Cool. What do we do next? We kind of want to do, you know, a very simple check. If response dot success or something like that. Can we even headers? The headers. What's in headers? Please tell me there's like a code or something. Contains key. We can also look at the content type to make it even more interesting. But I just want to find the error, success or failure code. Status. There you go. Status code. What can this be? What is status code? Non-zero U16. Okay. If this is equals to status code from U16, I guess, 200, then we can continue, right? So that's kind of, what's the issue here? Can't compare status code with result. Oh, this is interesting. Why can't I just have a function that returns me the success status code? String. I understand why there's an error, because you can give some status code that's not a valid status code, but come on, this should be a lot simpler than me having to. Oh, there you go. There's this here. What does this do? Macro rules, status code, impl. Oh, okay, so it adds an implementation. Okay, there is something easier than that. I was wrong. So it should be status code ... okay, right. Not dot. There you go. Right? Yeah. Finally. This isn't water, by the way, this is pure vodka. So I can keep up with reading shit code and writing shit code. Okay, so what do I want to do? I want to say if it's not the same, if it's not okay, we simply return like any, or we just bail, right? invalid response or something. Page return. Okay. And now, instead of all of this, what can we do? We can do response.text. Okay, and this it's just the same after that. Okay, a little bit better. So we shouldn't be visiting pages like 404 pages or anything like that. Is it going to help at all? Probably not. It's not going to change anything. It's still going to be slow as hell. But at least we don't visit irrelevant pages. Any messages on my Discord? Let me just check that real quick. Nothing interesting. Okay, going back to this. See, I still seem to sort of like stop at some point, and I have no idea why it's stopping. A link found, link found, link found. Acquiring the next link from 1. This is going to be interesting to debug. I'm going to wait a little bit to see if it actually returns. There you go. Could not find href link. Number of links visited too. It has been like a legit 5 minutes. Not 5 minutes, but you know. All we did so far is visit 2 links, which is cool. This is, I suspect, I have a very bad suspicion that this request get is using the same client object and therefore the same agent, even though it's like different threads. They're not running in parallel because I think it's the same underlying client object, right? And I'm about to test that assumption by changing the request code wherever I do it, because I get lost in my code way too easily. Here. Right, so instead of this, what is this doing? It would help if we actually read the documentation as well, right? I guess. So this function creates a new internal client on each call and should not be used if making many requests. There you go. We got our answer right here. So yeah, my assumption was slightly wrong. It doesn't use the same client. It creates a new one every time. So there's obviously some sort of like bottleneck if you're creating many clients all the time. So yeah, let's do that. Let's actually create a client by looking at the documentation first. So this is what we're going to do, create a client. Tell me there is a code snippet we can just copy and paste. Maybe not. Yeah, so on each sort of find links, I guess we can pass in the client here, because we can then create this client up our stack and use the same one for each call. So we have, like, if we have 4 threads now, we can have 4 different clients, right? That's my logic. And it should just be as easy as doing client.get, right? I guess. Yeah, it is. Now, what is the freaking problem here, though? Quest builder is not a feature. New client. What is a request builder? I guess it's like a builder pattern for a particular request where you can set headers. There you go. You can set headers, data, and whatnot. send seems to be the one. Yeah. This is actually very easy for us because it's just, I guess, client.get, and then we have .send, and then .await. Right? Yeah, got it right. Cool. And now, wherever we use find links, we have to create a client, right? Find links, which is here inside the crawler itself. I'm going to create my crawler outside this, so I can do a client equals client new. Does it have to be mutable? I have no idea. Let's see. Use of moved value. No. We don't want to move the value every time. We want to just take the reference, because I want it to be the same one every time. Client.get URL. Okay, it doesn't have to be immutable, does it? Because it doesn't seem so. Okay, cool. Now, essentially, we have that one client per worker thread. So they shouldn't be, firstly, it shouldn't be creating a new client every time, and it shouldn't also kind of be running one after the other. I expect them to all run at the same time. So let's see. How many have we already visited? Like, dude, not many. 14. It's not many at all. This is not very scalable. I mean, that guy's definitely winning on that, in that sense. Yeah. So the idea for today was actually to have something like this. We have the URL queue and the worker threads, and then saving it to the URL database. In the URL database case here, this is basically just a hash set of already visited URLs. But you know, we can swap it for a database later on if we want to, or a file, or whatever. Alright, let's see. I can't tell if it's running faster or the same speed. Yeah, I cannot tell this at all. It's still fairly slow. Safe to say that. And what's interesting as well is that my already visited, like this should be printing the output every 3 seconds. And this is clearly not, because there is something kind of holding the lock here. So maybe that's what's going on. That's why it's so slow, because one of these threads is definitely holding a lock. Hash sets are cool. I didn't know the longest Python. Yeah, Python dictionaries are hash sets essentially. Yeah, so there is something holding a lock when it's doing a request. And I have no idea why. I can't tell why. I don't know what is going on. I mean, what we could do is, like, we can put a, I guess, an info here. Okay, let's build this now, because I have a suspicion that it's like, that is the line that's blocking it. One of these links takes a long time to reply. There you go, finding links inside. What did I do? Finding links for I have so many logs that I don't know which one this is yet. So let's add that. Cargo build. See, this is all finding links for google.com. Finding links for google.com policy terms. And finding links for Google about. Is it just a case of bad deadlock? Because in here, I acquired the link one first and then released the already visited. Let's just do this for now. And here, I acquire the link one first and the already visited. Okay. And this is the reason why I don't like working with multi-threading programming or async programming involving locks. Because I will write something like this that has a deadlock in it and not know where it is. And it's still there. Or is it? A link found in this. Privacy. What is in Google privacy and why does it take so long? And in fact, let's just put a timeout in the client while we're at it. So we have, where are we? Let's find links. We have the response here. Timeout, is that a thing? There you go. Duration. Let's say we give it half a second to respond. No, it still messes up. It still doesn't. The point is, I have absolutely no idea what's going on. Maybe we have to actually debug this, which is going to be a pain now. Wow. So let's try that. I also thought I had an LLDB here. What is my arguments? What is env? I just want to add the Rust log here. Env. It doesn't give me an answer. Starting URL. Okay, now I just need to figure out how to add the logs. So env, let's go launch.json. I just want to see the format of it. It's an environment variable. There you go. It's just that apparently. Wait, what? No, it's not. Okay, cool. Is it just post log equals info? Yeah. Okay. Okay, let's try that now. At least I can step through this shit and see what... Maybe I'll be able to see what's going on. Or where it gets stuck. Okay, I see what the issue is. I'll just let this get stuck and then I'll pause the program whenever that happens. There you go. So this is where it gets stuck. Now where is it stuck? Is it going to tell me? In the call stack. Parser. HTML parser. Yeah, I seem to have an infinite loop somewhere. A parsing loop. I wish it told me where in my code it is. In fact, can I not just control? Is it like a node that claims to have itself as a child or something in HTML? That could be causing this, but I don't see why. I don't see how you can possibly do that, to be honest. The runtime has a lot of threads, Jesus. Harness, raw. I'm not sure if this is going to help me at all. I'm just hoping to find something. Panic. I just want to find it in my code where it is, and that's very difficult, it seems. Alright, dude, yeah, I'm not sure if it's going to help me at all. Jesus. Tell you what, let's just rerun with some breakpoints in very specific locations that we kind of think are messing up for us. Where is that though? So found link in is where I... So this is the last log I see.
And where's find link? It's used in here. So let's put one there and one there. Okay, so let's run this again and see if those breakpoints are hit. Found links is hit. I am gonna remove this breakpoint. Jesus Christ. There you go. Finding links. Which is already visited. Finding links. This is getting returned a lot. But not that. Error sending request for Google policies. Operation timed out. Cool. Let's just increase the timeout for now. Gosh. Let's say 3 seconds or 10 seconds. Yeah, Antonio, this is going to be very difficult to debug. I might not resolve it today. Next link, waiting for that. Desculpa aí, amigo. Finding links. This is where it fails, right? This is where we mess up. Let's see what happens. Already visited. Now it's finding a bunch of links that I didn't before. Interesting. Very much stuck now. See, this is definitely dead now. I have no idea what's going on here. Probably these links. Sorry, probably these mutexes have been freed. So we wait for the link queue. Could not find href in link. What in the hell? Is this actually broken? First of all, they don't seem to be requesting links in parallel. It's all the same, isn't it? Then it definitely fails here. It's definitely a dead link somewhere, a dead lock. And that place is definitely here. So we read there. What is the order of destruction go? In Rust, sorry. I dropped in declaration order. So let's see this. So we get link queue and already visited, and then we drop the link queue and they already visited there, and then here we acquire the link queue and they already visited, which means they are dropped when it gets to here, link queue first and then already visited. This doesn't sound bad to me, but I'm not sure if it's the opposite way that I should be doing things. So acquire multiple read locks from the thread, otherwise you may be deadlocked. Read recursive, okay, we can do that. No, we do not have that. What is this? Definition of parking lot. Okay, so. This means that the readers trying to acquire the lock will block, even if the lock isn't locked, when there are writers waiting to acquire. Because of this, attempt to recursively acquire the lock within a single thread may result in a deadlock. The parameters t represent data. Okay. We don't have that. We have Tokio read write lock. Allows a number of readers or at most one writer at any point in time. The write portion of this lock typically allows modifications of the underlying data, exclusive access, and the read portion typically allows for read-only access, shared access. In comparison, a mutex does not distinguish between readers or writers that acquire the lock, therefore causing any tasks waiting for the lock to become available on yield. Is fair or write prefer. Cannot starve. Okay, so I think there is definitely a deadlock in my code. You okay? Huh?
For some moments in life, there are no words.
What? Spider. Just say. Yeah, go in there. No. No one can see you, don't worry.
We are the dreamers
Yeah.
of dreams.
Wait a second. It's nearly bedtime for me. I don't think I'm gonna be able to solve this issue today.
If the good Lord had intended us to walk, he wouldn't have invented roller skates.
Dude, what the hell? This is fucked up. It's still locked. I'm gonna leave it running to see if it's actually deadlock or the request code somehow taking a lot longer than I thought. Try read, try owned. Is it one of the issues in the output function by any chance? It might be. It might be. Sorry if I do drop. It might be the stupidest thing, but we will see. No, we're still deadlocked. Still deadlocked. Now my brain is fried, and I'm definitely not gonna find this issue today. So I'm not gonna keep trying until I'm completely dead. I'm gonna save some brain power. I'm gonna push what I've got here with a non-bug, and we'll continue tomorrow. A gente continua amanhã, Cara, esse aí tá fudido. Esse erro aqui hoje não vai ser não, cara. Com certeza. Tem uns erros aqui da hora que aparece, mas could not find link. Href link. A request of response body. Operation timed out. See, this is just a timeout in operation. Error sending request to URL. Operation timed out. Operation timed out. So all of them are timing out after 5 seconds. So yeah, have a good rest. Isso aí, Antonio. Let's have a good rest. And then we can think about scalability tomorrow. How to make this quicker. Making the crawler. But we're deadlocked. Cara, se você quiser acessar o código, não sei se você já viu aí, tem um link aí na descrição, se você quiser ver como tudo funciona, cara. If you wanna, just saying that, if you wanna see how this code works, there is a link in the description, so you guys can access it. Although I think there's only Antonio watching this, no English people today. Mas é isso aí, cara. That's it for today, guys, and hopefully we had some fun. And I'm gonna definitely turn this off now. Você via hint computador questão? Não vi ainda não, cara. Eu já via que tinha... Como chama? Esse aqui. Was it Prime Sieve?
It was like, it was by a guy who used to work for Microsoft. You can so yeah, there's this competition. It was like a prime sieve competition. See, for compilers. I can't remember. Yeah, there you go. This guy here, Plumber Software. So David Plummer. So he made this competition to see which language provides the best prime sieve. So finding primes. That's the one I've seen. It's kind of similar to what you're saying, I guess. But yeah.
I would write it in all 3 languages as best I could, and then drag race them in no holds barred, no quarter asked.
A lot of people wrote their programs for this. And yeah, there's a massive list of the results. You can see the results somewhere. There you go. So I think at the moment, it's not surprisingly enough, the fastest ones are like Rust, I think. Or let's have a look. Reports per page. Yeah, if we just take a look at some of them, you can see the fastest languages. Architecture, course, user, date. I don't know how to see this, you see. Where's the language and whatnot. But there's multiple languages on this on the results here. It doesn't say which language it is, does it? Oh, there you go. So for this particular run, you can see the fastest language was Lisp, apparently. C++ coming on next, and then Rust is up there as well, I guess. But yeah, there's quite a few runs, and you can see which ones perform the best. But this, I guess, would be similar to what you mentioned. The compiler competition. Yeah, that's it, guys. I'm gonna definitely go now. Thank you for watching. Valeu aí, Antonio. And I'll see you guys later. Bye-bye. Have a good night.